All right, what's up, guys? In this video, we're gonna pick up with some calculus here, and we're going to find the radius and interval of convergence for the given series. That's what we're asked to do here. So we're given this series from k is equal to 1 to infinity. We got x raised to the 2k all divided by k squared. So to find the radius of convergence, and I do have videos on this, by the way, so you don't just have to look at this one example. To find the radius of convergence, you can use one of two tests. You can use the ratio test, and in some cases you can use the root test. A lot of people think that it always has to be the ratio test. It doesn't always have to be the ratio test. You can use the root test in some cases to find the radius of convergence, but you'll probably be using the ratio test probably a lot more. And that's exactly what we're going to use here. So let me write down the ratio test. So remember, for the ratio test, that's the limit as k goes to infinity. And it's going to be the absolute value of a sub k plus 1 all divided by a sub k. And that's going to be equal to L. L represents the limit. Now, remember, how do we determine the convergence? So remember, if L, again, which represents the limit, in this particular case, happens to be less than 1, then we know that the series will basically converge absolutely. So I'll write AB as for absolutely. We know that if L happens to be greater than 1, or let's say we get out infinity, it diverges. And then we know that if we get a limit that's equal to 1, we say that the test is inconclusive. So it's inconclusive. And basically all that means is you have to use a different test. Ratio test, won't work in this case. And if it's inconclusive for the ratio test, it'll also be inconclusive for the root test. So don't even try the root test because it'll be inconclusive for that one too. Okay, so let's start with it. So again, we're looking for the limit. This is going to be the limit as k goes to infinity. And all we have to do is we have to stick in a k plus 1 for every place we see a k, and then divide by our a sub k. So our a sub k in this case is just going to be x squared, or excuse me, x raised to the 2k all divided by k squared. So let's go ahead and do that. So if we substitute everything in, we'll have x raised to the 2 multiplied by k plus 1. I'm just substituting in k plus 1 for every place I see a k, then we'll divide by a sub k. And so then this will be basically k plus 1 squared. And then I'll divide all of that by the a sub k, which is the x raised to the 2k all over k squared. And that's the absolute value of all of that. Now remember, dividing by a sub k in this case is the same thing as multiplying by the reciprocal of this. So for example, if I want to divide the fractions, let's say for example I want to divide 1/2, again this is just an example. Let's say I want to divide 1/2 by 3/4. Well, that's the same thing as 1/2 multiplied by 4/3. Because dividing by this fraction is the same thing as multiplying by its reciprocal. So we can do the same thing here. Make sure you leave the absolute value bars up. You need those until we get to a point where we can take them off, but we're not there yet. Okay, so what will we have in this case? So this is just going to be x raised to the 2 multiplied by k plus, or multiplied by k plus 1 all over k plus 1 squared. And then we'll multiply by the reciprocal there, so that'll be k squared over x raised to the 2k. And it's going to be the absolute value of all of that. Okay, so now that you've got all that set up, you just have to clean it up a little bit. I'm going to leave the cleaning it up to you guys. I mean, this is pretty easy stuff to simplify. I'm not going to waste your time with that. I'm pretty sure you guys know how to simplify all that stuff. So just simplify that stuff a little bit. So we get we get the limit as k goes to infinity. And we'll get the absolute value Well, I'll simplify this a little bit. I'm going to bring the absolute value of x squared. I'm going to bring the absolute value of x squared outside. Now, remember, when we pull the absolute value of x squared outside, you have to, or when we pull the x squared outside, we have to leave it an absolute value. So don't take the absolute value bars off. So now on the inside here, if we simplify, we'll get k over k plus 1 squared. We'll have the absolute value of all that. Now, k is positive as it approaches infinity, so we can go ahead and take off the absolute value bars. We do have to leave it up for the x squared that's on the outside. We can also divide by the highest denominator power, which in this case is k. So we would divide k by k, and then 1 by k, and we can take the absolute value bars off. So we'll have absolute value a squared times the limit as k goes to infinity. And again, I take off the absolute value bars, divide by the highest denominator power, we'll get 1 over, basically 1 plus 1 over k. Because if I divide k by k, I get 1, k by k, I get 1, 1 over k, obviously can't do anything with that. So this just simplifies here, and then don't forget that's being squared. Sorry, I forgot to put the square up there. So that's where you're at now. Now we take the limit, which we'll do on another sheet. Okay, so absolute value x squared times the limit as k goes to infinity. It's going to be 1 over 1 plus 1 over k. Again, that's being squared. We'll take the limit. Well, that just gives us 1 divided by 1, which is just, well, it's 1 divided by 1 squared, which is just 1. So that means that we'll have L is equal to absolute value of x squared multiplied by 1. So in this particular case, our radius of convergence is 1. Okay, so that's our radius of convergence. And we know that because we square both sides. We square the, well, we mentioned the absolute value bars. So if we square, if we end up squaring, or take the square root of both sides, that'll give us the x. Because remember, if I take the square root of x squared, I get x, for example. So let me show you. If I take the square root of x squared, I get x. That's what I was trying to point out. So we'd essentially have the absolute value of x, which is less than 1. So therefore, the radius of convergence would be 1. All right, so that's part 1 of the whole thing. All right. Next thing is the interval of convergence. That's next. All right. So really, add the absolute value of x squared is less than 1. And remember that when we took the square root of both sides, we got the square root of x was less than 1. So we would have to find the intervals for the absolute value of x, which would just be x is less than 0 and x is greater than or equal to 0. And so we can write them as overlapping intervals. So in that case, I'm just going to write it -1 less than or equal to x, which is less than or equal to 1. Now, to get the interval of convergence, I just need to check the endpoints. Now, we had k is equal to 1 to infinity. And then it was -1 raised to the 2k all over k squared. So I need to check the endpoints for x is equal to positive 1 and x is equal to negative 1. So you'd have to check the endpoints, or negative 1 and positive 1 for x. Now, we know that these are going to converge because it's a p-series. So look, so to infinity. And when we check the endpoints here, we get 1 over k squared. Now remember, by the p-series test, that converges. So remember, for a p-series, if I have something like, let's say I have some series and I got 1 over n raised to the p. Well, if p happens to be greater than 1, then the p-series converges. So when we check the endpoints, and I don't even have to write down any further because the endpoints are 1 and negative 1, we know that this is going to be a converging p-series because the value of p here is 2, which is obviously greater than 1. So by the p-series test, that, this would actually converge. And so therefore, we could say that our interval of convergence would in fact just be what we got up here, which is x, or negative 1 is less than or equal to x, and then less than or equal to 1. And we know that these are going to converge by the p-series test. So therefore, if we go back to what we had at the beginning here, when they asked us to determine the radius of convergence and the interval of convergence for the given series, we can easily write down that our radius of convergence is 1, and then our interval of convergence will be what we got here, which is where negative 1 is less than or equal to x, and x is less than or equal to positive 1. So we'll write down the final answer. So our radius of convergence, that one, which would denote r, is just 1. The interval of convergence, negative 1 less than or equal to x, which is less than or equal to positive 1. So that's your radius of convergence and your interval of convergence. So for the interval of convergence, you just have to check the endpoints. So you check those endpoints. Okay, so I do got videos on these, so feel free to check out the other ones. Not that bad, does take a little bit of practice though, but that's basically how you get your answer. So let me know if you got any questions about it. Yeah, I'd love to talk with you about it. So see you guys next time.